Shall we start, by the way?
Chinmay will wait another 2 minutes. Let's see if participant more than 50, then we'll start. Okay. Another 2 minutes.
Okay, sure.
Already 41 has joined. Yes. Chinmay sir, you can start. Yeah. 12:08, you can start. If any questions are there from students that you can ask, then Chinmay sir will start the session.
Okay. I guess okay. I guess no more question. So what we can do is we can quickly move on to the next session. We can move on to the next session. Where's my slide? Mhm. Okay, I hope you can see my screen, right? Okay, there is something in the slide in the chart. Git repo poisoning. Okay, see, this is the name itself is suggesting what could be the meaning of this. Very simple, like you take milk, but you put a little bit of poison. It's no more milk. Poisoning is simply like you have a very big application, okay, and a lot of contributors are there. But what will happen if you put some sort of like malicious code into that repository, or you also create the pull request where you have some sort of like malicious code. There's also another type of poisoning. So poisoning at the end, the main intention is that let's break the security feature of the application. Simply, it could be also based on some sort of patch. It could be based on some sort of using the old library. So, for example, in your installation file, the requirement file, you put some previous version of the application. Previous version of the dependencies or the libraries, which are known to be vulnerable. So these are different techniques like the poisoning. So poisoning at the end is all about like the attacker or the other anonymous users. They try to poison the repository by putting some malicious code or the code which should not be put in the or should not be merged into the main repository. So that is what your Git repo poisoning. And for that, usually Git and few other tools are there who always try to scan what is the new code and whether that new code is affecting anything else. And for that also, there are AI tools are there currently which are managing all the codes, making sure that the merge is not breaking the security of the repository. Okay, now coming back to the next session. In this session, we'll talk about, okay, why? What I'll do, I'll try to switch off the video just to save some bandwidth, making sure that there is no lag. Okay, so in this session, what we'll do, we'll discuss on data intensive application containerization using Docker. So what we'll have is that, first of all, for the basics, you need to first understand that what is containerization, what is container, why it is required at all, what is Docker, how these containers and Docker, these two different terms are different or similar or same. So In this theoretical aspect, we will try to understand um, the life without Docker, the life without containers, and the life with containers. And then that means like we'll try to understand what is the motivation behind it. And then we'll try to understand what is the online concept and what are the different features and how you can use in your daily life. So, um, so I'm not sure if you are comfortable with cloud computing. I'm not sure about that one. Um, but in cloud computing, usually what happens is that um, you have different services. Let's not talk about cloud computing. Okay. Um, let's skip cloud computing because it may be possible that some of you are not familiar with cloud computing. So let's talk about the virtualization. Um, so in virtualization, before virtualization, what actually happened? What usually happened? The traditional physical server. You have the hardware. You assemble your PC or you assemble your server with multiple modules of chip or memory card, your different hard disks, storage devices, your networking card. You probably, if it is a big server, then you have two CPUs. If it is a personal computer or if it is a lower end server, then you attach one CPU. So and then you prepare your hardware. Then once it is on, then you put the operating system on top of that. Otherwise, you cannot communicate with those hardwares, right? And then again, on the top of your operating system, you put your application, right? So your application will interact with the operating system to get the services or to use those hardwares. The user application could be that it could be a database server, it could be a web server, it could be any other kind of software application or web application. And so the problem with that one is that what happens if you have or if your application require a different operating system or if your application for some reason um, top of your host operating system, if you install multiple applications, let us say 10 20 number of applications, then all the applications will basically interact with the host operating system, right? So if there is any crash in the host operating system, that will affect all the applications hosted on this operating system. So the other thing is that sometimes the sharing of the resources, for example, your CPU, memory, disk, network, and others, the sharing of those resources among all the application is not efficient enough. That is eventually affecting the utilization of all these hardwares. So one thing is that uh, one application may interact with other application. So from the security aspect, there is no isolation. So that means one application simply can access the data or the configuration of other application. It's also possible that the same application is deployed for multiple users. That means it's very difficult to stop one application, uh, one application stealing the data of other applications of other users. So at some point, from the security aspect, you need to have some sort of isolation between multiple applications. So what do you mean by isolation? Um, just imagine that you are inside a room and you don't see anything outside, right? So you feel that this is the whole world. Let us say if someone is inside a room for the entire life, for him or her, that is the entire life or that's the entire world. The moment you come out of the room, maybe you are again in confined inside a campus or inside a building. And if you spend the entire life inside that, then basically you will feel that okay, this is the whole world. The moment you come out of that campus or out of that building, then you will feel that okay, maybe this is the whatever you can see, whatever you can visualize, you feel this is the whole world. So the isolation is all about like you are restricting yourself or restricting one application from accessing others, and also restricting the application to access others data. So there is a very concrete boundary between two different applications. When I say application, it's the application code, it's the data, it is the libraries, everything. So for that, we come up with the concept called virtualization. So virtualization means what? You have again the hardware, and top of that your host operating system, or it could be some another specific layer called virtualization layer. And on top of that, you have again some CPU, memory, disk, network, some resources, but those are the virtual resources. And these are called the physical resources, and these are called the virtual resources. On top of that, you install some operating system, and on top of that, you install your application. So for this application, for the first user application, for this application, this is the only user, this is the only operating system, and these are the only available resources for for this application. So this application will feel or will think that there is no other application hosted on any other, or this is not a part of a physical or bigger physical server. This will feel that this is the physical server, or this is the actual server, and application is hosted on this one. So the job of virtualization is that if you have what are the X amount of resources, that will be divided into among, or that will be divided, or that will be shared among all the applications. Yes, is there any question? No, I guess. Um, so over here, what will happen is that um, through this virtualization layer, you can create multiple virtual environment, isolated environments, but in each and every isolated environments, you can deploy your applications. Okay, so over here in this application, if this required a Windows operating system, you can put Windows. If this application required Ubuntu, then you can install Ubuntu. If this application required a CentOS, then you can have CentOS operating system. So you can think of like the same hardware, but you have multiple operating system running at the same time. So this is how like also you can efficiently utilize or maximize the utilization of the underlying hardware infrastructures, right? So this will also increase the performance, the computing capacity. Uh, of course, I mean, in real, this is not actually, you're not increasing the computing capacity, rather, it's because of the utilization you are improving the capacity or the that is relevant to the hardware. Uh, so now the point over here is that, um, okay, yeah. So here, what do we see? If you see this picture, here you see the virtualization layer, right? Just top of your hardware, you have the virtualization layer. This is some sort of like, we call it also a hypervisor. This is also another type where it's not necessary that the virtualization layer will be directly installed on top of your hardware. It's possible that in between your virtualization layer and your hardware, there could be like a host operating system. And your host operating system is there, your virtualization layer is there, and top of that, again, you have your isolated environments. And usually this simple one box is usually also called the virtual machine. And by default, we call machine is like physical machine, but these small boxes having their own operating system, having their own virtual representation of the resources is usually called the virtual machine. So uh, now, so here these are the two different types that I was just discussing. So here you have the hardware and you have the virtualization layer, and this is called your hypervisor type 1. But if you have operating system on top of your hardware, and on top of your operating system, if you have virtualization layer, then this is usually called your type 2 hypervisor. And this is what you can use in your own laptop. Okay. Um, and this virtualization layer, for this, you can have different software tool. For example, Oracle VirtualBox is one of the most popular one. For this, it is also called bare metal hypervisor, because you don't have any host operating system, unlike this type 2 hypervisor. So these are two different types. Now, if you look at, yeah, if you look at this one, where like you have multiple physical infrastructure or physical servers, let us say you have your different, in your type 1, you have different physical servers. You also have the virtualization layer, and top of that you have the applications. We move from there to your host operating system, your hypervisor, and then your guest operating system for each and every application. And this is usually called the virtual machine. So if you look at, for each and every application, you have one operating system. Let us say your application itself is only 100 MB, let us say, or maybe 150 MB, but your operating system itself will consume a lot of space. Your operating system, it will take 10 gigabyte of storage minimum, or 12 gigabyte of storage minimum. So just imagine that you have 5 applications, each of 100 MB, a total of 500 MB applications, 5 applications, but only just to host those 5 applications in different isolated environment, you need to spend probably like 50 gigabyte of storage for your guest operating system. So this is really very, even if your application is smaller version or smaller size, but at the end, you need more storage because of this guest operating system. So for the sake of for the realization of realization of isolation to make the application secure, you are really um, spending a lot of storage for the guest operating systems. Now, also the other one or the problem is that the cold start, that means the moment you install or the moment you start a virtual machine, um, again it will take a lot of time. Sometimes it takes 1 minute. Just imagine just starting to start your application, it is taking 1 minute for the virtual machine to simply start, and then your application will start on top of that. So obviously, uh, every time you start the application, if your virtual machine is not running, then you need to wait for 1 or 2 minutes to start the virtual machine. Then only you can start your, or you can run your application. So that is what we call the cold start. That means it is taking a lot of time to start the application, which is not for the application code itself. Rather, it's just because the virtual machine, the way we implemented that one. Now, to tackle these two things, there is a concept called containerization. So in containerization, what happened? So you have the host operating system, your physical infrastructure, and on top of your host operating system, you have something called container runtime engine. So this is kind of, again, a kind of a, you can say, a small software tool. So here actually what happened, the application and the dependent libraries are tightly coupled, and each and every application will run inside a container, not inside a virtual machine, rather inside a containers. And each and every application, they will use the kernel of your host operating system. Before, what was happening is that each and every application, they will use their own different versions of the guest or kernels. But over here, each and every application, they will use the kernel of your host operating system. And this runtime engine, it will basically take care of how to start the container, when to start the containers, and other technical difficulties it will simply handle. So in this case, what happened usually, you are simply removing entirely the requirement of guest operating system. So the moment you remove the requirement of guest operating system, you are really saving a lot of storage space for your applications. So if you compare these two things, your VMs and your containerization, your virtualization and the containerization, then the difference is that it is very lightweight because your host operating system is always running. That means to start a application inside a container, it will take literally some millisecond or some second. Sometimes it even take less than 1 second. And of course, in addition to that, um, instead of uh, instead of being able to create only few number of virtual machine on a physical server, you'd be able to create thousands of containers on the same infrastructure. So obviously, your lunch time is fast, your storage utilization is much better, the other resource utilizations are much better. Um, it's very lightweight, so just in a few milliseconds, you'd be able to start the application. And but what is this container? And in reality, what actually how does it look like? Okay, so in reality, actually, there are like two different concepts are implemented. Um, So one is the namespace, the other one is the C group. They are the two different terms that are very essential to understand what is actually a container. So, uh, so namespace is all about. Uh, Before that, let me first clarify that when we talk about the resources, you may think about the time, you may think about the CPU, the memory, um, all this you can think about as the resources. So namespace is all about it limit what a container can see or can use. And C group is basically it will control how much one can see or one can use. So container is actually also called Linux container. Uh, so which is a Linux operating system OS level of virtualization because the virtualization can also be in different level, which we didn't discuss. Uh, so it's a virtualization method for running multiple isolated Linux-based um, containers on the single host controlled and managed by namespaces and C groups. So basically, whatever the containers you are creating, all those things will be implemented, will be handled and managed by two different tools called namespace and C group. So let's understand what is namespace. So as you can see, it will simply limit what one can see. Um, for example, like if you look at just the Linux system right now, you would be able to see different number of namespaces. So Linux namespace is just a partition of processes and system resources, so that only one process can see the resources in the same name group or namespace. If I give you some analogy, probably let me see if I have. Okay, I don't have. Okay, let me give you one analogy. Um, in a um, in an educational system, in an educational institute, you may have like multiple different rooms in different classrooms, right? So which class will be using in which will be using which classroom, that will be decided by someone else, right? So someone else will be there to assign particular class ABC. Let us say class ABC should happen in classroom 101 from time 6 to 8 p.m. or a.m. let us say. So for that, let us say there is some person who will be assigning these resources, right? Um, Similarly, that person will be basically dividing the into all the classrooms and assigning each and every classes to different classrooms. Maybe let us say there is another person who will be controlling that and making sure that you are using, or the class teacher is using their classroom only from the assigned time period, only for that time period, not beyond that. So you may say that, okay, someone may use 6 to 8, and someone may go beyond 8. But for that, again, there is a person who is called C group who will make sure that you are not going, or you're not using the classroom beyond 8 a.m. or beyond, whatever it is. So, so that is what the two different concepts. One which will partition the entire resources, and the other one which will control based on that partition. And if you look at your console, your terminal, and if you insert this command lsns output all, then you will be able to see different namespaces. NS stands for namespace, different namespaces. For example, process ID, that means how the IDs of the process should be distributed on the users, the MNT or the mount, the time, the C group. And so if you take the example of process ID namespace, then usually what happens is that uh, the root process, whenever you start your operating system, and definitely there might be some program which will run for the very first time. And that one will have some ID called 1, let us say, okay? So from that program, obviously some other programs will start executing one after another. So one, it will have, let us say, 2 child processes, 2 and 3. Maybe 2 is having 1 child process that is with ID 4. 3 is having maybe 2 child processes with ID 5 and 6. 6 might have 1 child process with the ID 8. But again, 8 might have 2 child process, 9 and 10. But since it is a one namespace, this is a different namespace. For that, within that namespace, this process will have another ID called 1, and its child processes will have different IDs, 2 and 3. So for this process, child process, for this, the root is this one. And for this child process, this is the entire system. So this child process cannot see anything beyond this boundary box. Okay. So this is how like you partition the process IDs. If you look at the file system namespaces, then usually you'll have the root file system, and over here you'll have within that root you'll have bin, drives, var, dv, and some other folders in the Linux system, I'm saying. And within the drive, you might have, again, inside the drive, you'll have /01 directory. And again, inside the /01 directory, you might have, again, replicating the same file system. For example, root, bin, dv, and all this directory structure. So for this bin, definitely root is only this one. And anything inside this bin cannot see, or any other folders or directories cannot see beyond this root file system. So this is how your file system namespace actually work. So if you look at the broader view of the file system namespace, you have the root file system, you have bin, proc, procedures, users, var, lib, and a lot of host file system. And inside var, you might have lib file system, lib directory. And inside lib, you might have containers directory. And inside containers, you have multiple containers are there. So this containers is just a directory. And inside this one, you might have container 1, container 2, container 3, and different directories you might have. And basically over here, each and every container, within that containers, you might have, again, an application of the host file system directory structure. So inside this my container, maybe you will have bin, procedures, users. Sorry,
Hay nào qua cái?
any question?
Nếu quán là cao người hay.
Okay, so inside this container, you might have again the replication of the host file system. So the moment any process running inside bin cannot see anything beyond this area. So it cannot see or it cannot access any file inside file leaf. Any process running inside this bin also cannot access any file outside, or for example, any file inside bin, procedures, users, var, leaf, home, and the host file system. So the process running inside this bin for that file systems, right? So this is how like you create a namespace, you isolate that process inside that file system namespace. Okay, and this will create an isolation. And because of this isolation, you create some sort of security, a secure boundary of that for that application. That means the file of or the processes of other containers cannot also see anything inside this container. So that means you have actually different containers, and for within each container you have different processes are running, and one process cannot see the file structure or any other process IDs or process namespace of other containers. Okay, we need the PPT service. Uh, you mean the PPT after this session? I guess so. Yeah, I mean PowerPoint. I'll share this one. So this is how the broader view of the file system namespace. Uh, okay, but when it comes to the C group, uh, it's basically a feature for isolating and controlling the resource usage. Uh, so this will make sure that a process running in one container should not be or or it's not accessing the processes or any kind of assets of other containers. And for that, your C group will continuously monitor this one. Again, if you assign only 100 megabyte of memory to one container, then any process running inside that container or any program running inside that container cannot use more than 100 MB of memory. But how to ensure that one? For that, you have this C group. So namespace will simply assign 100 megabyte of storage, sorry, 100 megabyte of memory to that container according to your requirement. But it is the C group which will ensure that the process or the program running inside that container is not using more than 100 megabyte of memory. And that means for that, the C group needs to continuously monitor each and every containers. So, um, so yeah, I mean, for this, so C group provide the following features. It's, for example, the resource limit, also the prioritization. It means that even if, let us say, your hardware itself, you have only 4 gigabyte of memory you have in your laptop or in your PC, um, but uh, but let us say you have 10 different containers you're running, and each of them is accessing or is trying to use 500 megabyte of memory. So 10 um, uh, 10 containers or 10 processes is requiring 500 megabyte of storage. Maybe that means definitely you need to have more than 5 gigabyte or more than 4 gigabyte of memory on your systems. But when the demand is more and supply is less, at the time, uh, it's the job of C group to make sure that which container is of highest priority, and accordingly it will share those resources or it will assign those resources to that containers. So that level of prioritization is something implemented by this C group. C group is also accountable. That means it should monitor, it should report that which process is using which resource and how much. It should also control the status, for example, whether the memory uh, should be freeze, or it should be frozen for one containers. And basically, those kind of control is enforced by this C group. But here question arises that the moment you create a container, you need to create the namespaces, you need to configure the C group. So everything, a lot of things you need to do. So you need to uh, partition the all the resources. Resources, when I say the CPU, the memory, the network, the process ID, everything you need to implement. So instead of doing that one by yourself, just to create one container, there are different tools out there which will allow you to create a container seamlessly without any effort. So using those tools, for example, Docker, Podman, CoreOS, Archetype, Linux Container, OpenVZ, these are a lot of different tools out there. Like you just provide the instruction, then what you want to do. Let us say you want to create one container. Then in Docker, you just create the one line command, and the Docker will simply create or will implement the necessary partition or necessary configuration for that single container. So you don't have to do that one. So that is where like basically, or that's the reason why all these different tools are much more um, popular nowadays. So in this session, mostly we'll discuss about Docker. But obviously, like the moment you understand Docker, the moment you are comfortable with Docker, definitely it will not be very difficult for you to understand and make yourself familiar with other tools. In addition to Docker, obviously, Container D is also another popular one. Podman is also another popular one. LX is kind of a very old one, which is the initial implementation of containers, which is obviously popular one, but mostly Docker and Container Ds are in use. So far, any confusion? Okay, I guess no. So let's move on to Docker. So again, it was initially launched in 2013, mostly written in Go programming language. So basically, when you run a container, Docker basically will create a set of namespaces for that container based on your configuration. So though it is like 2013, it is launched. So they launched the first commercial product in 2016. Uh, so if you look at the overall architecture, the very bird eye view of the architecture, then you will see that there is one client. You have the host, Docker host, and then you have some registry. And inside the Docker host, you have the containers, you have the images, you have the Docker daemon. So what eventually happen is that all the instructions that you want to do or that you want the Docker to do, for example, creating a container, stopping a container, removing a container, all those commands basically you provide through a CLI. And then that will be sent to the Docker daemon. So Docker daemon will now make sure that container is created or container is removed based on the image. And registry is nothing but simply a registry of all the images, Docker images, or simply the container images. We'll discuss what is that image. Now, let's quickly discuss about what is the container now and how it is different from Docker image. Before moving on to or before understanding what is Docker image, I'd like to give you a recall on the previous understanding of simply an OS image. So whenever you start your personal computer. If it is a brand new one, and let us say you want to install an operating system. So for that, usually what will happen is that you come up with some ISO image, let us say Windows. For that, probably you have a CD or a DVD, or like the image is installed, the operating system is installed, um, and basically you use that image to install the operating system on your PC. So just imagine that the similar ways, uh, the Docker image is kind of a blueprint based on which you create multiple containers. So for example, in your if you go back to the previous example, in your operating system, if your Windows operating system, if there is an ISO file or the image file, that is basically always a read-only file. You cannot modify that one. And based on that read-only file, you create the multiple instances. You can use the same ISO image file um, in the same CD disk. You can use the same one to install the operating system in hundreds of or thousands of personal computer, right? So that is how the Docker images also work. So this is a read-only one. So that means you cannot modify the existing content of that image. Of course, you can add something on top of that, but you cannot modify that one, the existing one. So so basically, this is an image which which basically will tell you the blueprint how the container should behave and what the content should be. And container is nothing but the instance of that Docker image. Okay, so it means like how to say, yeah. So it's basically the instance when it runs. Basically, that is what your Docker container is, and your application is always running inside that container. So that means your application must be also inside the Docker image. So how then usually this Docker image usually work? That's something later on we'll discuss. Now, Docker engine is a small software tool you need to first install. Otherwise, you cannot issue any Docker related command. Registry is again kind of uh, is a registry of all the images. For example, GitHub, where all the repositories are stored. Sorry, where all the repositories are stored over there. So what usually happen over here is that in Docker Hub, whenever whoever will create an image, he or she will simply upload that image to the Docker Hub, which can be accessed by others. Uh, if your image is public, then anyone can use that one. If it is private, then definitely some credential is required to access that one. But it's just a registry of all the images. Now, some of the basic command. For example, once you install Docker, then Docker version is basically you see the version of the Docker. You pull the image. Okay, so this is something we'll discuss in the demo time. Okay, so how the Docker file should look like. So Docker file is basically uh, simply a text file where you give the set of instructions how to build the Docker image. For that, you have this Docker file is there. And for that, again, you have a set of commands are there inside the Docker file. For example, from working directory, copy, run command, different commands are there to build your own Docker image. Now, if I want to give you an analogy, you can create your own version of Linux operating system, right? Linux-based operating system like your Ubuntu, Lubuntu, Xubuntu, Kubuntu, Kali Linux, and a lot of different operating systems are created, right? Uh, and all those operating systems are created on top of some base kernel, right? So the similar ways, what you can do by yourself also, you can get the any operating system. You can modify that one by yourself. let us say by default in the Linux-based operating system, you might not see some browser, let us say Brave browser, you will not see, or let us say Opera, you will not see. I'm just assuming. So what you can do, you create the base operating system, you take that one, you put your own, uh, you can customize that one by yourself. For example, for the cybersecurity related things, you take the basic or the basic operating system, the kernel, and you add or you install a lot of different security related tools. For example, some tools related to scanning the network, scanning the port, or analyzing the code, if the code is secure or not. You can probably install some AI related models, deploy that one inside that image, um, and that is how like basically your Kali Linux is created. Okay, so Kali Linux is basically created on top of this basic operating system by adding a lot of security related tools. Okay, so the similar way in the Docker image, um, from is there. That means you provide what is the base image. Let us say Ubuntu 18.04 or Ubuntu 22, or it could be Python 3.8, some base image you can choose. And on top of that, you can modify you can add some more files, and based on that, you build your image. Uh, Now, question here arises that how you manage the data over here. Usually, what happens is whenever you create a container, you modify that container, or if that container is generating some data, and the moment you remove that container, the data will also be lost. So you cannot persist that data. So what you need to do is that uh, you have different ways how to manage the data. So even if the container is lost, even if the container is no more, but still you can have the data or the modified data persistent. And that you can do with two different ways. One is volume and bind mount. So volume is like, let us say over here. So let us say this is your host file system or the host system. You have some memory. You created one container. You have some file system. So when you create a volume at the time, the Docker will create a folder or directories kind of structure inside. So your volume will be created somewhere inside the Docker area, inside this area. And your container will use that directory or that volume. So even if the container is no more after modifying the volume, but still all the modifications will be persistent inside this volume. So what you do is just create a volume, and then you basically run in, you create a container, and when you create the container at the time, you say that please use the volume. How to do that? We'll see this one in the demonstration time. Also, the other way is that your you can basically bind some folder inside your file system, and you can bind that one with the containers. So container, whenever it will use, when it will start running, at the time it will use the volume or the file system of your host um, operating system or host file system. The other one is tempfs. So tempfs is um, another type of how to say um, data persistent storage, but it's actually not. It will not allow you to store the data. It's a kind of file system, small file system, which is inside the memory. And usually this is used when you have some sensitive data you want to store, or you want to provide some sensitive data to the container when the container will start. So some sensitive information, for example, some users credentials, some API keys, some internal endpoints, let us say, or any kind of like some sort of like internal environment variables. Those things can be provided through this temp fs. So obviously, this one is like it's a temporary. So once the container is gone, then basically the when the container will stop, the temp fs mount will be removed, and the files written there won't be persistent. So well, this is not actually the data will be persistent, but this is what you use when you have some sensitive information you need to share with the container. Um, okay. Okay, so let's move on to the demo time. So what we'll do is that we will first build a Docker image. We'll first look at some of the basic command, and after that we'll create a build image. We'll build an image, and then how you can share that one, and then how you can run that, how other member can run that system, run that container. So let me stop sharing this one. But in the meantime, if you have any question, you can ask. Okay. So here it is. Give me a second. Okay. Yes. Does privating a GitHub repository can protect it from the attackers? Yes, definitely. Um, it will simply add another layer of protection if you make it private. Because if it is a public, anyone can simply access that one. So when it comes to building a proprietary software, at the time, usually the repositories are private all the time. In most of the cases, it is private. Of course, they create a public version of that application. Um, if you look at the open source community and also few other businesses, if you see, I've seen many businesses who like what they do is that they will first create the prototype, they'll make it open source, uh, and then on part of that, once they are kind of the stable and they provide the minimal features, uh, after that they will create a private version of that application. Okay. uh, so mm, for example, let us say Docker itself. So Docker itself is actually it started with the open source. So that means the repository was public. After 3 years, when they build minimal features, after that they create the private version of that repositories. So in the private version, basically, um, they have advanced features which are accessible only by the um, subscriber. So if you pay or if you buy the commercial version of Docker, then you will be able to access those features. So yes, um, does privating a GitHub repository can protect it from the attackers? Yes, it adds a new and the layer of protection, and that layer of protection is basically provided by GitHub. So you don't have to do that. Okay, now let me share the screen. I hope you can see my screen. Okay. Uh, okay. So here I'm using a Windows operating system. So what I did is that I installed Docker Desktop. So if you just Google it, download Docker Desktop, then you would be able to um, find it very easily. And also you would be able to install it. If you are not using Windows operating system, if you are using, let us say, uh, Mac or Linux based operating systems, then you can use the command, some installation command in the that is available in the Docker itself. So here I'm assuming that your Docker is installed. Just to look at the version or to verify whether the Docker is installed or not, you can say Docker version, and then here this is what your 28.1.1 is the version of the Docker. So first we are discussing about the images, and we are discussing also about the containers, right? So let us see the list of containers that is currently running over here. And for that, you can use Docker PS. So here you can see the container ID image. That means this container is created using this image. What is the command? We'll discuss that one. When it is created, what is the current status? What is the port number it is using? And what is the name of that container? So Docker PS is showing nothing, but what will happen if I say Docker PS minus A? So Docker PS minus A is a flag which will tell you that give me all the containers, even if those are stopped. So for example, this one, this is the container ID. This is the image. Then this is the command we'll discuss. What is that command? And this is what when it is created and when exit, and what is the name of the container. So the name of the container, uh, it can be left blank. So if you don't provide any name, then basically your Docker will provide a random name to the container. So to see the list of containers, simply Docker ps minus a, which is all containers. But if you remove a, then only the containers that are running you can see. Now, to use, it's better you sign up and sign in Docker Hub. But after that, yeah, listing full image. Now, so we saw that there is no containers currently running. Now let's look at what the different images. But if you see the list of all containers, then here you'll see this is the container and this is the image. So one image, we know there's something called Flask Docker app. This is also the same image, but the IDs are different. That means two different containers are created using the same image. This is also another container which is using Nginx image. So that means if I want to see the list of images, at least I should be able to see these two different images, right? And for that, what I can do, Docker images. And then here you can see that, okay, those two at least images are there. This is one, this is another one. Okay. Yeah. So here you see that at least these two images are there. And of course, we have more number of images, but using those images, there is no container, not even a stopped container. Here also you will see for each image, you will see the tag, some tag you can see image ID and when it is created and what is the size of that image. So you can see the Ubuntu image, Docker image is of size 117 MB. Nginx is the web server and the image is 279 MB. Okay. Now we know, okay, there are some images out there and there is no running container. Now let's create a container using some image, let us say Ubuntu. Okay. So what I'll do, Docker run Ubuntu simply. This is the image name. Okay. Now you saw, okay, I mean, it doesn't give any output. Why? But if there is a container running or is a created, then at least we should be able to see that one in Docker PS. So Docker PS is not showing anything. That means at least the created container is currently not running. It could be possible that it run, started, and then again it stopped. If it is stopped, then we should be able to see that one using /a. So this is what you see. This is a container using image Ubuntu. There is some command 32 seconds before ago it started, created, and then exited 30 seconds ago. So that means it was live, it was running for 2 seconds at least. So now here you see the containers are usually short-lived. From here, one of the conclusion is that the containers are always short-lived. For example, like if you want to create if you want to run a Python file, then if the Python file is calculating something or calculating some or running some program, then it will start, it will run, and then it will exit. The similar way the containers are. The container will be created, it will run, and then again it will exit. But what will happen if I want to um, run something inside the container? So what I do, container run /it and Ubuntu /bin/bash. So what I want to do over here is that, oh no, okay. So here you see Docker run, you understand run is to create the containers, and IT is basically the interactive mode. So what I'm saying is that I'm telling Docker to create a container using the image Ubuntu, and inside that container, you run the cell terminal, and that terminal should run, and it should allow me to interact with the system, with the container itself. So that means you start. I told Docker to start the cell terminal in interactive mode, and that's the reason why I have. You can see I have a different terminal here. If I look at ls, then you will see the traditional, although those default directory structure of a Linux-based operating system. Bin, dev, home. So I'm basically inside this container. Okay. Now, if you want to see whether the containers are running or not, what I'll do, I will create a different terminal, and inside that terminal, I'll see ck docker ps. Here you will see that this is the container. Currently, it is running. Status is up about a minute, created about a minute ago, and the command is sh. And if you look at, if I go back to my previous terminal, here when I created the container, at the time I given the command sh. And this is what you see when you list the content list of containers, you will see the command is sh. So here, what I see that I have a container which is currently running using the image Ubuntu, and the command sh is currently running inside the container. Now, what will happen if I close that terminal? So that means let us exit. So now I'm outside the container, and let us see if the container is still running. The container is stopped, so it's now not running. So this is where, like, you see the different stages of the container. It will start, it will be created, it will be started, it will be in the running stage, it will stop, and after that, if you want to remove, then you can remove. But for that, you need to have some command. So for that, you can use docker rm, and then the container ID. So container ID was, where is the container ID? This is the container ID, right? B978359. So I need to provide the container ID B97. So the good thing is that in Docker, you don't have to provide the whole ID. The first 3 characters you can provide. So the first three characters of B97. So what you can do, you can simply give docker remove and B97. So B97 is the first three characters of the container ID. Now the container is removed. If you want to see, sorry, there is no container running with the ID started with B97. So here what we can do, docker remove. You can also remove multiple containers, 76A 257 space 257 space 843 space 498. Now it removes everything. ESA. Now there is only one left. So there is something also we can remove. Docker rm EE2. And now, sorry, there is no container running, and at the same time there is no container in the stop stage. So this is how you use run command. We'll see other kind of flags or the options. So let us say I want to use the web server. I want to create the web server. So for that, let us say I want to use the Nginx images. So what I'll do, docker run in Nginx. So in this case, what will happen is that Nginx will run inside that container, but the problem would be that you cannot access that one because the web server is running inside. What is this? Okay. So the web server is running inside the container. You cannot access that one. And that is for the benefit of your isolation. But the question here is that if I want to run a web server, but if I cannot access the web server from outside, then there is no meaning of isolation. So what you need to do is that for that you need to map the port number of that container inside that container where the web server is running, and map that one with your host operating system or the host port number. So for that, what you need to do slash so dash p 80 colon 80. So the first 80 is basically the, okay, let me give a different one, 82 and then 80. So 80 is the port number of your Nginx inside their container. Okay, so it is running now. And let's try to see, can we access that one? So URL curl localhost, comma, okay, no, definitely the port number we gave 82. So here you can see Nginx. Thank you for using Nginx. And we're able to access this one using the port number 82. Using the port number 82. So whenever from the outside the container, if I want to access anything through the port number 82, now Docker knows that any request coming to the port number 82 in the host operating system, those requests will be forwarded to the port number 80 inside the container, inside that Nginx container. So if you see over here the list of Docker PS, then here you will see the container is running, and it's still running in a healthy state, and the port number is 82 and 80 with the protocol TCP. So this is what the benefit of port mapping. This is what the benefit of port mapping. So unless and until I stop that one, you'll not be able to come out of this loop. So currently it is, you are inside the container. So what you can do is that you might want to run the command, or say run the Nginx web server in the daemon mode. So that means in the background. So what you can do is you can simply use run -d, that is in the daemon mode, and then run. So now it is running. So if I want to access this one, curl localhost 82, sorry, it's 82. I should be able to access this one. So these are some of the essential features in the run command. A few others. Uh, let me try to go to how you can create the volume. Uh, so, okay, we have 10 minutes. Docker run, sorry, /it Ubuntu. So what I'll do, I'll also give a name to that container, and the name is first one, and then Ubuntu. So here you can see that Ubuntu is running and I'm inside that container. And let us say I want to see what are the different file system inside the container. Yes, these are the file system. What I'll do, I'll go to home, and then I'll see, okay, Ubuntu is here. Sorry, Ubuntu, and then let me create a directory. Directory is KIAT. Okay, now I will exit from that container. Okay, I exit. Now what I'll do, if I remove that container, I cannot access this directory anymore. So what I'll do is that I will first, to make the data persistent, I'll first create a volume, docker volume, create volume 1 or 1.1, let us say. Okay, now when I'll use that, I'll use this volume. Let us say, what is this? Yeah, volume 1.1 container. And what I'll do over here, I'll map. For that, I'll use -v. And then what's the volume name? Volume name is vol11. And it should be mapped to, let us say, home and Ubuntu. So volume 1 is the space or is the directory outside the container. And inside the container, I want to map that one with home/Ubuntu. Okay, now let's start. Okay, so I should not be, okay, it's okay. mkdir, let us say /home Ubuntu, there is nothing. Let's create one directory, home Ubuntu 1 directory. Okay, now let's try to see if the directory is there. Yes, the directory is there. Now let's exit this one. So now we exit. Now let's remove the container, volume 11 container. So what we'll do, we'll remove this container, docker rm vol11 underscore container. Now, next, whenever we'll create a new container using the volume vol11, we should be able to at least see this directory, right? So how we'll do, let's create another container, and let us say the container name is volume11 container 2, let us say. And here also I have mapped this volume with the directory over here. Let's see. Okay, now I'm inside this one, home, Ubuntu. Now here you can see the one directory is still there, but we are inside the container volume11 underscore container 72. And the ID of the container is 0037. But before, when we are creating this directory, at the time we were inside the container with the ID F34E. So here you can see, even if the container is stopped, even if the container is removed, still you should be able to access the data which is modified by the previous container. Now the question arises that how we can containerize an application. So how we can run our application inside that container. Okay, so I have created a Flask application. So this is the last part. So I have created a Flask application, and let us say, where's this application here? So in the Flask application, we have Flask. It will simply, if you access this one using the port number 5000, it will simply show the in the web page hello from Flask in Docker. Okay. So what I want to know, sorry, what I want to do is that I can simply run this application directly over here using the Python command. Or what I can do, I can keep this program inside a container. But for that, I need to create the image. And for that, I need to first create a Docker file, because Docker file is the basis of creating a Docker image. And Docker image is the basis for creating a Docker container. So what I'll do, I create the Docker file. I've already created this one just to save some time. So from is basically in the image, the base image should be Python 3.11. And then the working directory is /app. So it's something like uh, when you log into a Linux, what is the default directory will be. So that is what your working directory is. And then copy the requirement file inside that container or inside that image. And the requirement file is already over here. And install all the packages inside mentioned inside the requirement file. So Docker, so requirement file inside that we have the Flask. So this is just a Python libraries. So install that one inside the image, copy what are the files inside the current directory. So that means all these three will be copied to the Docker image. Then expose 5000 port number, because your web application will be exposing, will be available on 5000. And then run the command python app.py. So it's something like when the container will start, definitely there should be a program which will be executed first. And that is where we want to do. So, sorry, the discussion is like, the explanation is like, whenever the content will start, which files should be executed or which application file should be executed first. And that is where your command is all about. So what we have over here is that, so this is the Docker file. Okay. Now let's containerize this one. So what you will do is Docker, sorry, let me first remove RMI Flask. So RMI is the removing the image. Slash Flask. Oh, sorry. In Docker RMI. Come on, not this one. Slash Flask Docker. Oh, underscore. Oh, sorry, the tag is v1, v0. Yes. Okay, so I've removed these images. So first we will create the image. So Docker file is already prepared. Now we'll create the image. So for that, we need to be first inside uh, the directory Flask app. So what is this? What happened? cd2/docker cd Flask app. So over here, I have the application code. I have the Docker file. I have also the requirement file. So what I'll do over here is that, sorry. So here you need to use the docker build command, docker, come on, build, and then you provide some tag and then some name, Flask, let us say docker app. Oh, sorry, I made a mistake. Flask docker app should be build, and so dot um, is basically saying that the docker file is present inside or present in the same directory. Give me a second. Yeah. So now it is in the building stage. So here the application, the image is created. So if I see Docker images, so here you'll see, oh, I should be giving a different name. Let us say. So let us see Docker images, and this one is just created 4 hours ago because, okay, it's already there. Okay, so basically this is the command because the Flask Docker app is already there, so that's why it will try to use the same image and it will create a copy out of it, and that's the reason why it is so quick in building the image or preparing the Docker image. Once it is there, then you can simply Docker, you can simply run that Docker run /p, and then your port number, let us say 5002. 5000 is the host port, and then your Flask Docker app, that's one. So here you can see the Flask application is running inside the Docker image, inside the container. And if I want to access that one, okay, maybe what I can do, come on. So localhost, and then I'll use the port number 5002. Oh, sorry, local.
Chinmak, can you add, Mr. Students are doing with you parallelly, or just give some assignment so that if they are going to do after the session, then they can ask their doubts.
Yeah, after the session, they can simply repeat the same thing.
So should I share these recordings, or PPT will be shared so that they can, until unless they are going to do parallelly, so they are not going to.
I guess this is pretty much okay if they want to get the recording of this one. This
Okay,
is pretty
fine.
much okay.
Okay,
Yeah.
so I'll provide to them so that they can practice and tomorrow they can ask the doubts.
Yeah, sure. Okay, but if you are sharing the recording, probably need to see. I hope I'm not sharing any.
Okay. So later we'll share, but so my point is just ask them to do it parallelly at least.
One thing I can do, I can share this code.
Yeah. So you just share it. So I will share in the group so
Yeah.
that they can do it. Okay.
Yeah, so they will have the access to this code at
Okay,
least.
fine. So
Yeah.
recordings later we'll share. Fine.
Yeah. Yeah, so this is how like my Python application, your Flask application is running inside a container. So once the image is built, now what you can do, you can also share that one with others. And for that, obviously, you need to log in. And once you log in, then you tag the image in a way, you tag the image using your username. So Rich is the username of my Docker profile. So this is the application, Flask Docker app and Docker app. And so this is, let us say, _1 v0. So once I do this one. After that, what I can do is I can simply post this one. So what I'll do is Docker post. So what will happen is that this is the username, Ricino is the username, and this is the image. So this image will be uploaded to my Docker Hub profile. So now others can simply, even you right now can simply access this one. You can simply download this one and run in your own PC. So here you can see that how I created a container, how I containerize an application, the existing application. I containerize that one. I build the image, and then I simply post that one to my Docker Hub profile. And anyone around the world, your team member can simply access that one and then use that one. So it's much more secure in a way that once your container is running, no other container in the same system can can access without permission. So in that way, the containers are much more secure. Now, but how you manage the data in this case? So obviously inside the container, you're not going to put the data. So for that, usually what happens is that if you know that your application will take probably 1 hour to execute or to process the data, then the preferred way is not to have the containers, because containers should be running for a short duration of time. But in your application, maybe there are some features which might be running for a few minutes, let us say 10 minutes or 20 minutes. And in that case, you might need to, or you might prefer to containerize that piece of code and run that container whenever you need. So this is what so when it comes to the data-driven application containerization, at the time you decouple the data, you look at what the application code, you decouple both of them, you containerize that one, and then that container can access the data maybe through the endpoint, any API request. So if your data is inside a data repository, some database, let us say QuestDB or InfluxDB or MongoDB or SQL, then each and every database, they do have their own URL and user authentication base, right? So your container can access the data, process the data, and can send the data to somewhere else. And container can simply stop and remove. So obviously in this case, you can see that whenever there is a new piece of data, your container will start, it will be created, it will process that new piece of data, and then it will send the processed data to a different database. So this is where your container is used in a data intensive application. And of course, it is also very, very secure in a way that no application is running. If there is no new data, then that means your database is isolated, it's not accessible, and it can be only accessible when there is a new piece of data, and that new piece of data will trigger the creation of a new container, which will process the new piece of data and send it to the send it to a different database. So in that case, it's much more secure as well. So this is all about your Docker. And if you have any question, you may simply ask right now, or you can send a message.
Okay, any questions from your side? Lipsa?
But definitely, I will share this piece of.
Okay, you just share the code so that they should practice, so that tomorrow, if any doubt is there, they'll ask, then we'll start the session.
Yeah, there's something definitely we can do.
Okay, then, so this much for today. If any questions, then you can take, otherwise we'll stop here.
Yeah.
Okay, then, thank you, Chinmay sir. Again, tomorrow we'll meet. Huh?
Yeah,
Thank you.
Thank you very much. Yeah, bye-bye.
Bye-bye.